Welcome to today's lesson on Tools of Astronomy. You'll need a copy of your Tools of Astronomy guided notes for this lesson. Your objective: describe electromagnetic radiation, explain how telescopes work, and describe space exploration. The vocabulary that you need to familiarize yourself with is refracting telescope, reflecting telescope, interferometry, and spinoff. The radiation from the universe that scientists study is electromagnetic radiation. Electromagnetic radiation consists of electric and magnetic disturbances traveling through space as waves. The human eye can only sense a limited range of all various wavelengths of the electromagnetic radiation, and this is called visible light. As you can see on this little picture over here, visible light is actually a very tiny piece of the whole spectrum for electromagnetic radiation. Let's talk about telescopes. Objects in space emit radiation in all portions of the electromagnetic spectrum. The benefits of using a telescope: the ability to modify telescopes with different detectors and mirror shapes to observe all wavelengths, especially those the human eye cannot detect. The human eye does the same thing with visible light, but the eye is much more limited. A human eye pupil has a diameter of up to 7 millimeters when it is fully dilated in the dark, whereas a telescope might be as large as 10 millimeters in diameter. The area of the opening through which electromagnetic radiation enters determines the collection power of the telescope. The larger the opening, the more electromagnetic radiation can be gathered. The ability to collect large amounts of electromagnetic radiation allows astronomers to observe faint or weakly emitting objects. A telescope collects electromagnetic radiation from a distant object and focuses at a point where the image of the object can be studied or recorded. It allows astronomers to use specialized equipment. A photometer is an example of using specialized equipment. It is used to measure the intensity of visible light. Telescopes can be used to make time exposures with the aid of cameras or other imaging devices. Refracting telescopes are the type of telescope that uses lenses to focus visible light. The first telescopes were invented around 1600, and they used lenses to bring visible light into focus. Reflecting telescopes are a type of telescope that uses mirrors to focus visible light. In 1668, a new telescope was designed by Galileo that used mirrors to reflect instead of lenses to refract the light. Concept check number 1. How do the various types of electromagnetic radiation differ from each other? Question 2. What are the advantages of using a telescope compared to making observations with the unaided eye? This would be a great time to pause the video, answer the questions to the best of your ability, and then resume play. How do various types of electromagnetic radiation differ from one another? In wavelength or frequencies? 2. What is the advantage of using a telescope compared to making observations with the unaided eye? A larger light collecting area, sharper images, and the ability to make time exposures, and the use of instrumentation to analyze light. Telescopes at other wavelengths. Astronomers observe the universe at wavelengths that human eyes cannot detect. Pictured here are different types of radio satellites. For all telescopes, the goal is to bring as much radiation in as possible to a focus. Infrared and ultraviolet radiation can be focused by mirrors in much the same way of visible light. X-rays cannot be focused by normal mirrors, so special designs need to be used. Because gamma rays cannot be focused, telescopes are designed to detect extremely short wavelengths of this type of radiation and can determine little more than general direction from the rays it comes from. Interferometry is the process of linking separate telescopes together so that they act as one telescope. If you notice on the lower right hand corner, there are multiple telescopes that are together. Those are all linked so that they are getting the best picture they possibly can. The detail in the images that are produced improved as the distance between the telescope increases. So for the interferometry, if you move those out further, the image is going to become clearer. Satellites, probes, and space-based astronomy. Astronomers often have to send their instruments into space to collect the information they seek. One reason for this is that the Earth's atmosphere blocks X-rays, infrared radiation, ultraviolet radiation, and gamma rays. Another reason is to make close-up observations and to even obtain samples from nearby objects in the solar system. Pictured here is the Hubble Space Telescope that is being released on April 25th, 1990. Spacecrafts. Space-based exploration can be achieved by sending spacecraft directly to the bodies being observed. Robotic probes make close-up observations and sometimes land to collect information directly. Probes are practical only for objects within our solar system because stars are too far away. Pictured here is the Mars rover Curiosity. It landed August 5th, 2012. This SUV-sized explorer has one mission: to look for evidence that Mars has had conditions favorable to support life long ago. Over the past 10 years, it has driven about 18 miles and has climbed over 2,000 feet. It has analyzed over 40 rocks and soil samples. It has studied the skies and taken pictures of shining clouds and drifting moons. It is also collecting data on the amount of radiation that Mars is getting so that future astronauts will be prepared and safe. The most significant finding of Curiosity would be the liquid water as well as the chemical building blocks and nutrients needed to supporting life were present tens of millions of years ago in one of its craters. Human spaceflight. Exploring objects in space has been a top priority for scientists, but they also have been very interested in exploring the effects of space, such as weightlessness. Space shuttles provide an environment for scientists to study the effects of weightlessness on humans, plants, the growth of crystals, and other things. Because the shuttle missions last a maximum of 17 days, long-term effects must be studied in space station. So, pictured at the left here is the International Space Station. It is a multi-country space station that is ideal environment to study the long-term effects of space. Concept check number 2. Number 1. What is interferometry and how does it affect images that are produced? 2. Why do astronomers send telescopes and probes into space? 3. How are space stations beneficial? This would be a great time to pause the video, answer the questions to the best of your ability, and then resume play. Concept check number 2. What is interferometry and how does it affect the images that are produced? 2. Interferometry is the linking of separate telescopes so that they act as one large group. The images have much more detail. 2. Why do astronomers send telescopes and probes into space? Telescopes are sent into space to avoid effects of Earth's atmosphere, which blurs images. Probes obtain close-up measurements and images, and in some cases, obtain samples for analysis. Question 3. How are space stations beneficial? They provide long-term, weightless environments for various experiments and tests. Spin-offs. Space exploration programs have benefited our society far beyond our understanding of space. Many technologies that were created for space are now used all over. Did you know that the technology for the space shuttle's fuel pumps led to the development of pumps that are used in artificial hearts? Or that the Apollo program led to the development of cordless tools? In fact, more than 1,400 different NASA technologies have been passed on to commercial industries. A spin-off is a NASA technology that has been passed to commercial industries for common use. Each year, new technologies are developed that not only benefit astronomers and space explorations, but also society.